Precision. Precision is defined as a percentage of true positive cases versus all the cases where the prediction is true. That is, it takes into account the true positives and the false positives. Precision equals to true positive divided by all predicted positives. Precision equals to TP by TP plus FP. Going back to the forest fire example, in this case, assume that the model always predicts that there is a forest fire irrespective of the reality. Remember, irrespective of the reality, the model is predicting forest fire. In this case, all the positive conditions would be taken into account, that is true positive. That means prediction is yes, reality is yes. And also it is taking into consideration false positive, that is prediction is yes and also reality no. In this case, the firefighters will check for the fire all the time to see if the alarm was true or false. You might recall the story of the boy who falsely cries out that there are wolves every time, and so when they actually arrive, no one comes to his rescue. Similarly, here if the precision is low, which means there are more false alarms than the actual ones, then the firefighters would get complacent and might not go and check every time, considering it could be a false alarm. This makes precision an important evaluation criteria. If precision is high, this means the true positive cases are more, giving lesser false alarms. But again, is good precision equivalent to a good model performance? Why? Let us consider that model has 100% precision, which means that whenever the machine says there is a fire, there is actually a fire. In the same model, there can be a rare exceptional cases where there was actual fire but the system could not detect it. This is the case of the false negative condition, but the precision value would not be affected by it because it does not take Fn into account. Is precision then a good parameter for model performance?